with 2.6 in the finance book, and 2.6 is on continuously. And continuously compounding interest is like saying, what if the bank has a computer program that's calculating your interest a million times a second? Okay, so continuously is like infinitely. Like your interest is being compounded every second of every day. Okay, but let's quickly review. There are 3 types of interest formulas you learned. One is simple interest. And simple interest is there is no compounding effect. So interest is simply your principal times your rate times the amount of time. The second one that was covered in 2.4 and 2.5 was compound interest. And compound interest gave us the total in our account, and it looked like this. Principal times 1 plus the rate divided by n to the t times n. And we use this formula when n is daily, weekly, monthly, quarterly, and so on. So when there's a specific time frame, we use this formula. The last one, and we're going to be covering that today, is continuously compounded. Meaning the bank is continuously calculating your interest. And that, it involves a new button on your calculator. P times E to the R times T. So on your calculator, it would look like E to the X. On Desmos, it's just the lowercase e, and then you have to hit the exponent button. But there is an E button. And so today we're going to be talking about continuously compounded interest. So I'm going to do some examples with you that are going to be similar to what you're going to see in the homework. All right, so here we go. Here are some worksheets. So I'm going to skip, well, I can go over one. Given the function f of x, as the values of x increase, what happens to the values of f of x, right? It'd be like saying, if I wanted to test it, if I started with 1, and then let's say I made it 100, if I tried those two values out, what would I get? Now, I have a calculator. You can use Desmos. The only downside to Desmos is the glare underneath my dot cam is too much, so you won't be able to see it under here. But I'm just going to plug in, I'm going to see what it does so I have a clear answer. Well, I'm going to change this to 10. And when I divide it by, I should have apparently left a lot more room. I got 123,499. When I make it 100, so let's see what happens as x gets bigger. Now it's only 12,349.99. So as you can see, as x is getting bigger, f of x is getting smaller. All right, as the values of x increases towards infinity, what happens to the values of g of x? And so here's my function. I kind of wrote on it a little bit from the last one. So I'm just going to test a couple points. Let's just see what happens. You can make a guess, or we can plug in, let's plug in 1, 10, 100, right? Because it's saying x is increasing. So if I plug in 1, I have 3 times 1 minus 19. I get negative 16. Now I'm going to change that to 10, sorry, minus 19. And I got 11. Now I'm going to change that to 100. And I got 281. So as x is getting bigger, what's happening to y? Y is also increasing. So I'm going to say that g of x is increasing. So building a table, I like to use 1, 10, 100. They're easy numbers to plug in. So that leads us into this next one. So here's our function. As the values of x increase, use a table to find out what happens to h. And so that is exactly what I'm going to do. Here's x. H of x just represents y. So I'm going to start with 1, 10, 100, 1,000. Okay, I could keep going, but I think that'll give us a good idea of what's going on here. So I'm plugging them into this function. So parentheses 8 times 1, right, I'm putting 1 for x, minus 3, divided by the bottom, 4 times 1 plus 5. And I got 0.56. So now let's enter 10. So if I just use the arrow up, I can change this to 10 minus 3 divided by 4 times 10 plus 5. Okay, I got 1.71. Now I'm going to try 100. So as you can see, y values are getting bigger. So I'm just going to re-enter this 8 times 100 minus 3 divided by 4 times 100 plus 5. I got 1.97. Now try 1,000. 8 times 1,000 minus 3 divided by 4 times 1,000 plus 5. And I got 1.99. So I can keep going, but it looks like my values are getting closer and closer. Like if you tried 10,000, I got 1.999. So these values are getting close to what number? It's getting h of x. I'm going to put is approaching 2 as my answer. It's getting 1.99999. It's pretty darn close to 2. So all of these are practicing that very thing. This is another way to write it. So this is looking for the limit. This right here is what we just did in the last two problems. What's the value or limit of y as x gets closer to, sorry, this should say closer, not closes, to infinity. Okay, so I'm going to use a table. I'm going to use the same values here. I'm going to use 1, 10, 100, and 1,000. So 10 divided by 1, this is going to be 10. 10 divided by 100, that's 0.1, 0.001, 0.000001. So what do you think the limit is here? As x got bigger, y is getting closer and closer to 0. So in the last one it was 2. The one before that it was just a general value. So I'm going to do the same thing in number 5. I'm going to build a table. So x, f of x, so 1, 10, I'm going to go a little bit smaller here, 20. So 2 to the first power, when I plug in 1, I get 2. 2 to the 10th, when I plugged it in, I got 1,024. 2 to the 20th, when I enter 20, so it would look like this, 2 to the 20th. Whoa, I got, let's see here, that's 1,048,576. And it just keeps getting bigger and bigger and bigger. So I would say that x I would say that f of x is approaching infinity. You could also use the infinity symbol, which is a sideways 8. Okay. The next one is just like the others. Number 7. If you deposit $1,000 at 100% interest, what will your ending balance be? So first, let's calculate interest. So I have $1,000 times 1 year times 100% would just be 1.00. That would give me 1,000. So my account would be the 1,000 I started with plus the 1,000 interest. I would have $2,000 in 1 year. Too bad I'll never find that kind of interest rate. All right, so numbers 8 through 12, we're going to be using, they want us to compare simple interest, daily compounding, and continuous compounding. So in number 8, if you deposit $10,000 at 1.85 simple interest, what would your ending balance be after 3 years? So simple interest, right? It said simple interest, so 10,000 times 0.0185 times 3, and I got $555. So my account would have $10,555 in it, right? Because I started with 10,000 plus 555. That would be my account balance. This next one says compounded daily. So notice for the first one it said simple interest. So I used my simple interest formula. This next one, compounded daily, I'm using the formula that involves daily. So I'm going to be using this one. So A equals 10,000, parentheses, 1 plus my rate, divided by daily is 365, to the 3 years times 365. So remember, we enter it just the way it appears, 10,000, parentheses, 1 plus 0.0185 divided by 365 to the, parentheses, 3 times 365. Notice the use of parentheses. Okay, and I got 10,570.67 cents. So far, you can see that with simple interest, I only ended up with 10,555. Compounded daily, I ended up with about $15 more. Now let's look at compounded continuously, which is a new formula. A equals P times E to the RT. So my account is 10,000 times E to the 0.0185 times 3 years. So I'm going to enter that in my calculator, 10,000 times, and then I have to shift to get my E button, but notice the E comes up and it already does the little arrow for me, 0.0185 times 3, and I get 10,570 and 69 cents. So it's only, 2 cents more than compounded daily. So they're pretty close, but I'm going to guess the more money you have in your account, the more different they would be. So number 11, if I'm comparing compounded continuously to daily, continuously earned 2 more cents, like literally like pennies. How much did the account that was compounded daily earn compared to simple? So it would be this minus that, which looking at it, that's $15.67. Okay, next page, couple more. All right, so let's do some more practice with that compounded continuously. So Eric deposits $4,700 at 1.03% interest for 5 years. It says compounded continuously, so I'm going to use that E button. So I'm going to use my principal or my deposit times E to the R times T.